Welcome. So we have a trebuchet, and this is a physics class, and we're doing physics in kinematics as part of projectile motions. And the parachute was hurling as a hurling machine. Okay, and throws a large stone across towards the wall. The machine was not placed and near the wall actually. Initial velocity 28 meters per second, and an initial angle at 40 degrees. The speed of the stone, that's what we need to calculate. If it hits the wall at the top, let's say we need to find out just as it reaches the top of the parabolic path. So it reaches the top, that's the top, and then we have a wall. Okay, that's the halfway. So we have two halfways, the first and the second one. Now we're going to show that when you calculate. And then this is the stone, and that's the wall. And we require the speed as the stone reaches the top. So let's get what we have right now, the given data we have. Okay, we need to find out that what is this vertical speed at the maximum speed. So vertical speed is 0 at top max. Maximum is 0 at maximum height. And then the speed of the stone 2D, we have the vertical and horizontal, and we have the vertical is the root of the vertical squared and the horizontal squared, but remember vertical is 0, so we have the horizontal only. And the horizontal velocity is equals to initial velocity multiplied by cos theta. And our initial angle there, that's 40 degrees. So 40 degrees as our initial angle. And then we need to, our initial speed is 28.0 meters per second. And then those are the given values, and then we know that horizontal, that's going to be 28 meters per second multiplied by cos 40 degrees. It's going to be cos 40 degrees. And punching that in a calculator, let's see what we get. Okay, so we have cos 40 degrees multiplied by 28 is 21.4 to 3 significant figures. 21.4 meters per second. The next question is the big question. Said when it has decreased half that height. So we need to know the time for the second half. So we have two halves. When it goes up and then when it comes down, it also meets the very same height. We have from 0 to highest, and then from highest to 0. And then at max, we have at max top, we have velocity y is equals to 0. And we know the equation of velocity, vertical velocity. So we need to just click it up. Okay. Vertical velocity is going to be initial velocity multiplied by sine theta minus, because of the gravitational acceleration, minus gt. So 0 is equals to initial velocity multiplied by sine theta minus gt. And then we have gt is equals to initial velocity times sine theta, and then solving for t, there we have t as v initial multiplied by sine theta divided by gravitational acceleration, which is g. So that's the equation for the time. So time at max, that's what it's gonna be. And Now we have equation for time for maximum height. We need to use y at maximum height is going to be, because we now have the time will tell whether it's at the top or not. So it's v initial multiplied by sine theta multiplied by time minus half gravitation multiplied by time squared. Okay, so that means we substitute. So what we do, we now substitute t in y max. So substituting that is gonna be y max is equivalent to initial speed multiplied by sine theta multiplied by v initial multiplied by sine theta. Remember, that's our equation for time at max, over g minus half gravitation acceleration multiplied by v sine theta v sine theta all over g squared. And that means now we have multiply both sides, that times that, so that's going to be v initial squared, and sine theta times sine theta, that's sine squared theta all over g minus that's going to be half, and then that's going to be v initial squared, and then sine squared theta, all that over g. So remember that g over g squared is going to be g, and then that's going to be over g, and then simplifying further we have, remember, 1 minus half, the same thing, so it's going to be half of that, positive half, v squared sine squared theta all over g actually, and then that's equals to max. Okay, and then we have a half of height, so height will be that, so that will be half of that, so it's going to be half bracket a half of v, okay, remember that's v squared over sine squared sine squared theta, remember that's over g, so that's over g there, is equals to half times half, that's quarter v initial squared sine squared theta, all that over g. So that simplifies to v initial squared sine squared theta over 4g. So that's the equation for half the distance coming down or up, it's the same thing. And then we need to find, remember the down and up will differ further as we calculate, so we need to find time at half height. So that time there at half height we'll have two of them, remember, so we need to initial plus squared times sine squared theta over 4g, remember that's the height. So the height is going to be the equation for the height displacement, that's going to be v initial multiplied by sine theta, all that multiplied by time is equals to half g time squared. So here we need to find now the time at half. Okay, so there we were just finding the height, so now find the time. So we have v initial squared sine squared theta is equals to 4g. So multiply both sides by 4g to get 4g v initial sine theta multiplied by time. That times that gives us 2g squared t squared. Now with that equation, so we take that to the left, the sign changes from negative 2g squared t squared to positive 2g squared t squared, and then that becomes negative. To the left that becomes negative, so which is negative g v initial sine theta multiplied by t plus v initial squared sine squared theta. All that equals to 0 because we took everything from the right. So the right becomes 0, and now we need to solve for t. So that part is a, that is b and c. So we have to use quadratic. So using quadratic equations, we need to know the values of a, b and c as highlighted above. Now we know that a is 2g squared, b is negative 4g v initial sine theta, and then our c is v initial squared sine squared theta. And now using the quadratic equation, so solving for t plus or minus, because the plus is coming down, the negative is going up. So negative b plus or minus square root of b squared minus 4ac, okay, over 2a. And then we substitute. Negative b is gonna be positive 4g v initial multiplied by sine theta, and then plus or minus square root of, we have b is negative 4g v initial multiplied by sine theta, all of that squared, minus 4. We have a as 2g squared, that's 2g squared, and then c is v squared sine squared theta. Okay, and all that over 2, and our a is 2g squared. The next thing we need to do is simplify. So that's time again, plus or minus. Remember, I said plus is actually coming down, negative is going up according to our equation on quadratic. So 4g v initial sine theta plus or minus square root of, so we simplify the top part. So the top part is going to be, that part there is going to be, we square everything inside, it's going to be 4 squared is 16, g squared g squared, v initial squared is v initial squared sine squared theta, all of that minus, so we multiply whatever we have there, is going to be minus 8, 4 times 2 is 8, g squared, and then we have v initial squared and sine squared theta. That's what we have. All that divided by 2 times 2 is 4, so it's 4g squared. We simplify further. Any moment we see for simplification, we use it. So it's going to be 4g v initial sine theta plus or minus square root of 16 minus 8. They're the same thing, so it's going to be 8 there, positive 8g squared v initial squared and sine squared theta. all over 4g. You can see that our equation is becoming smaller and smaller as we approach the solution. So that's going to be 4 g v initial sine theta plus or minus, so we have root 8 is going to be root 4 times root 2. Root 4 is 2, so it's 2 root 2. So we have 2 root 2, and then squaring everything there gives us from g squared to g, v initial squared to v, sine squared theta to sine. We root all that what's inside, so that's what we get, and then divided by 4g squared. So you can see our equation becoming simplified, and now we can see we can factor 2 and gv initial, so it's 2 gv initial sine theta. We can factor that, so factoring that will give us 2 plus or minus now it's gonna be root 2, because we factor 2 there, all over we have 2g over bracket 2g, so the 2g cancels out, and then we are left with 2 plus or minus root 2 over 2g, and that, remember, multiplied by, so that has plus or minus, okay, all that multiplied by v initial sine theta. So that's what we get. So we take the plus sign in with plus and minus. Remember, plus for coming down because it's going to take longer, and then 2 plus root 2 multiplied by v initial sine theta all over 2g, and then that is the time it takes for it to descend. So it's going to descend at that part, and then all we can substitute and get the value, but we need to get the exact, so we need to get the equation before we substitute it. So we have v initial final at half the descent, half the height as it descends, is going to be v initial sine theta minus gt, and then what we have there, we have to substitute the time, so it's going to be v initial multiplied by sine theta minus g, and then our time now becomes the time of descent. That's 2 plus root 2, all of that multiplied by v initial multiplied by sine theta all over 2g. Now you can see that the g cancels out, so our equation can be simplified further to v initial sine theta minus, you have 2 plus root 2 multiplied by v initial sine theta all over 2. So that's what we have, and now we have to substitute that. So we have, can just get some space there. So we have 2, that's initial speed, so 228.0 meter per second multiplied by, which is sine 40 degrees, that's our angle, sine 40 degrees, and then minus, that's 2 plus root 2 multiplied by our initial speed is 28.0 meter per second, and all that multiplied by sine 40 degrees. Okay, and all of that divide by 2. Remember, we have to divide by 2, so we have v initial there, so we take the first part, which is so So yeah, which is 28 multiplied by sine 40, that's 17 comma, we're not gonna round off yet because we're gonna round off in the final answer, 17,991 meter per second. So we check this other part. Remember this part there, yeah, it has to be divisible by yeah, that plus, yeah, so we have divide by 2, so we have to divide that other part also by 2 as part of the equation. Okay, so we have answer multiplied by 28 multiplied by sine divided by 2 gives us negative 30.7245, whatever. Okay, negative 30.724598 meter per second. And now we have to simplify that further. 17,991 meter per minus 30 gives us negative 12,7. So negative 12,7 meter per second. And that information there lets us that, okay, so that's the vertical component. So we know that the horizontal component we already calculated was 21.4 meter per second. So 21.4 meter per second. So the horizontal doesn't change because it doesn't, when the horizontal component doesn't change because it doesn't have influence from gravity. So speed of stone as it reaches half at y is equals to y max half on descent. That's going to be, we root the sum of the square of the velocity. So we know that vertical speed is 21.4 meter per second, all that squared, plus our horizontal one is negative 12.7 meter per second, and all that squared. So squaring that gives us 21 squared, root of 21.4 squared plus negative 12.7 squared is 24.9. Yeah, 24.9. That is meter per second. That means 3 places. Okay, 3 precision places, and then that's our answer, 4.2. And then the next question, let's say they want percentage, how much faster as it moves in part B. Part B is where we're solving half the distance coming down, and it's the final minus initial minus the previous, and then over the initial multiplied by 100. So 24.9 minus 21.4 divided by 21.4 meter per second. The unit cancels out, percentage has no unit, so it's got cancels out. So we have multiplying that by 100. Let us just check in a calculator. Our calculator is going to give us 24.9 minus 21.4 divided by multiplied by 100, that's 16.4. So our final answer is 16.4 percent, and that's the final answer. Yeah, this question took me a lot of time. I spent about 2 to 3 hours. Like everything took me a couple of hours to get it done. So please don't hesitate to follow or subscribe. And this is your tutor, Black Adam 5D. Any question, any comment, leave below. Yeah, follow from Facebook, subscribe from YouTube. Yeah, it's just token of appreciation. Thank you.